Hello, hello. Welcome to our latest stream. So as you saw, we are starting to sort of separate the brand just slightly to have a little bit more focus and a mutual brand with Adrian on the Wednesday and the Thursday streams. So generally, the Thursday streams, unless there's an exception, will be about more tactical, more engineering focus, architecture like today. And the Wednesday streams are more on the sort of the leadership and the CTO side. And whatever fits the bucket. It might just be leadership specific or culture specific without having a specific role or vertical to align to it. But Adriana and I are experimenting with it. So for now, we're slowly rebranding. So you might see a new logo pop up here and there, or a little watermark pop up here and there. But that is our intention for the end of the year, for the beginning of the next year. The important part is that we showed up, that I managed to show up, that we have a topic, and we're excited about it. So today we're discussing CQRS and actors. Primarily CQRS and the sort of patterns that make up CQRS, and then drawing a parallel with the actors. So I will have a sort of architectural overview for you. So I really like to highlight Eve Go11's description of it and his metaphors that he uses and his sort of connection to event sourcing and event modeling. And just before the beginning of the stream, like 30 minutes ago, he did actually mention, he posted a new post about it, and then I recalled he had a very good talk about this on Technorama. So I got his slides, and he gave me permission to use his slides. So we're going to look over his slides. He was talking about something very similar here. But it's just, he just has, you'll see in a moment, he has like super sexy slides about this topic. But let's start at the beginning. Hello. If you're in chat, let me know. As always, your questions will be taken very seriously. So if you want any kind of more detail, less detail, a little bit of more of a deep dive on some peculiarity, do let me know. I am monitoring chat actively. So first of all, how are you doing? How is everybody? I think we have about 15 people live. It's a nice number. 15. Yeah, there we go. That's a nice number. What do we need to mention? Yes, so CQRS is, so in the book, there's a book, obviously. So this is the book. You probably know this book. This is where most people get to know CQRS. From what I understand, the term itself was coined by Greg Young. So Greg Young is also one of the more stronger proponents for domain-driven design that heavily relies on events. So I see a lot of architects in the industry use domain-driven design, but they sort of shirk away from the idea of having domain events. They're just modeling something so that they can sort of map out the architecture dependencies and then rely on the tactical patterns. And I think the domain events themselves carry the most rich information, along with the ubiquitous language and the processes that go into really the core of domain-driven design, which is dealing with Conway's law for the primary part, right? So the way how communication happens between the people who are doing implementation, that determines how coupled and how chatty certain API elements will be. And that's very unintuitive, and that is a sort of socio-technical nature of architecture and software architecture. Now, what we're doing today is a bit playful. It is this idea, and I got this sort of catchphrase from Eve Go11, that most, and we'll get to this in the slides, most architecture patterns can be expressed using 9 very simple tactical patterns, right? So if you look at the systems design, most of it, the data flow in that design can be expressed usually, like most applications can be expressed as a combination of 9 very simple to understand patterns. And there are, half of those, like 4 or 5 of those patterns. If you combine them together, what you get is actually CQRS, as we'll see later. And then the actor, so part 2 of today's talk, what an actor is a stateful implementation of those patterns, usually used for high concurrency, where there is some locality of state being maintained. And you might have heard the word aggregate before, so there is some parallels there. I don't think we'll practically get into the details today on this call about what is an actor, what is an aggregate, or is this DDD, is this sort of compatible, not compatible? There's a very good video on that, focusing on Akka, but because I never used really Akka before and I'm not that well versed with the language, I will just link the video at the end. Remind me if I forget, please. And then we'll just dive into it now. So I first learned about this in this book. Where did you learn about CQRS? Because a lot of people that I talk to, they understand CQRS to be this thing that is the root of all evil, which is eventual consistency. So when you use CQRS, you'll get eventual consistency. Now, that's not true. Is it even in this book? It's called something else in this book. Did I mix up the books? Oh, no, it is the other book. Oh, I don't have it with me right now. Sorry. It's the integration patterns, not the application architecture. Anyway. How did you get to know CQRS? That's what I'm curious about. So I have a little bit of delay with chat. So if you do want to join in, do let me know. So the architectural pattern, sorry for repeating myself. It's just, I'm so used to, yeah, Ricardo, hello. Ricardo, I can't see your chat in Steam, unfortunately, but it's lovely to have your life on the stream. Yeah, I think we all have that book. Usually, Adrian, when he's on the stream with us, I usually peek at his bookshelf behind him, and you can always see what books people are reading. It's this book and Code Complete and the Refactoring and one of the Agile books and Accelerate, and I have Implementing Lean Software Development, and we're now in the book club we're reading the book Accelerate right now on DevOps, but that's more of a topic for Wednesdays. Let's see. Okay, chat is working, but yeah, looks good. Looks good. So let's start with the slides. This is the first time I'm using the. Ooh, that looks very nice. Oh, that does look very nice. How's the quality? Can you read the text? Yes? Okay. And do cursors work? Ooh, cursors work. So, particularly about what Yves Goleman was talking about regarding CQRS is that most of the messaging patterns handle the change of data over time. And I'm also writing about a sort of temporal coupling series on my newsletter on this on this newsletter. Hello. So there is, let's say, there isn't a lot of things you can do with time because unless you're showing something very much UI focused, like a monitor stream. So the difference between showing something on your screen versus recording it and encoding it into a video medium. Okay, we got a nice comment on the. Oh, but I don't see them. Okay, it's gonna be double duty on the backup chat. I saw your message. I just need to refresh. Vikas, hello. So Vikas, I'm very sorry. I won't be able to sort of show you on like I usually do with the tooltip because my comments aren't showing up in my streaming software. I'm very sorry, but I did receive your link. So Vikas recommended this Microsoft link. I mean, you can see it here. I'm just for the YouTube viewers, those of you who are joining late or on the other channel. So it's a Microsoft Orleans. What is this? Is this a framework? It's a framework, right? So it is a actor. So it's a framework that heavily relies on actors. I'm not familiar with it, but it seems like this is very much similar to Akka and Akka.net. It is usually a framework that handles heavy concurrency that uses actors to deal with this sort of the main architecture, the main sort of core pattern, opposed to say MVC for a kind of web or integration technology. But we're jumping ahead. Vikas, thank you for the link. I'll definitely show it on stream in a moment. So this idea of event modeling and event sourcing is that unless you're showing something live to the user on some UI, there is generally something going on with data. And data generally only flows in three particular segments. Either something did happen, which is the sort of what you would call persistence, some fact about some past event that, yeah, this has happened. Now you might delete that, and then we saw evidence that it is not deleted. Yes, it doesn't exist anymore. That also counts. The negative also counts. Then there's the present. This would be your what I see on screen, a state of something, a property of something. You are watching me. That is present data. You not only do you see the pixels, but you also see how the pixels change in your screen over time, right? So this is a slowly evolving state that is sort of changing state. And if you've ever done Redux or any kind of React framework, Angular, new Vue, Next, you're probably exposed to this because the past tense of these data flows is usually what you would use something like a middleware for state management, whereas the present data flow is more similar to something like animations and transitions or retry policies regarding some kind of connection or third-party API connection that has to happen live. And it really captures this idea of, did it happen and it's important in the past, or is it happening right now? And then you also have the futures, which it's a bit harder to think about, this word future. It's about the user clicks something, the user does something with the expectation that there will be some follow-up to it. That's why we call it a future, right? So it's not that it's, yes, what I see often people do is they model a command as if it's an event. The user has decided to click this button, and then they put it into past tense. But what really matters is not that they have clicked the button. What matters is that they have sent out a command, and now this command has to be processed. So I think this idea of commands is a bit neglected in the sort of the blue book on DDD. But this is a very important concept. It then picks up this idea of commands in event storming. But I think event modeling, which these colors are event sourcing and event modeling, right? So these colors are referencing the colors of event modeling and event sourcing. So yellow or orange being booking received, that's an event, it's a past thing. Green would be a projection or like a state of something. And blue would be a command, a user interaction. I think event storming colors these red to denote a actual human doing it right now, opposed to purple, which would be a automated, like an automated command. For example, the user has scrolled and then stopped for 5 seconds. That is an automation from the timer, not so much fun. So if you would, if you're building something like Instagram, a user scrolling and then stopping, that is a command triggered by a timer based on something that the user did, but it's still considered a command even though the robot initiated it. So I really like this distinction because it simplifies it down. Ricardo, yes, I find this slide very insightful as well, and it really boils down well into why there's 9, right? So I keep saying that there's 9 patterns that make all of this event modeling happen, and you can see 3, 9. Of course, there's a before and an after. So there's a trigger and a response, a request and a response. And it is basically the matrix of these 3, past, present, future, basically multiplied with each other. It's the Cartesian product of all of these combinations of event flows. And we will look into that in a moment. I just need to deal with my technology today. So just to check on if I missed on any of your comments. Do let me know if I'm going too fast or if you would like me to sort of linger on a particular topic. I know sometimes I'm waffling a bit, and I blame myself for that, but I do need a little bit of. It's much easier when I have a co-host and they're correcting me live. It's a bit harder with comments, and there's a slight delay on the comments. So the idea here is that the data flow, the manipulation of data flow that you're modeling with your system, the underlying data mechanism, 99% of them will fit into one of these three categories. So saving something to a database, that's an event. Saving a outbox pattern, a message to a database, that something has to be processed, that's a command. Having a view or a select all from and then join and then put it into a cache, that's a projection. And also everything that you would generally call a DTO that is then being sent to some front end, those are all projections, right? So it's this super simplification of just having like a, let's say, architectural level terminology and a sort of time-based cadence of, why do I call it this? Well, because it has already happened and it is certain. Well, why do I call it this? Well, because it is explaining future intent. Last time on the temporal coupling video, the temporal coupling stream, I discussed this idea in the similar context of the subscription, the invoice and the transaction, right? So the subscription is a future. The subscription says this person is subscribed and there will be something in the future. And then it's the sort of the invoices that are happening that are really connecting the futures with the present. It was like, oh, now it's time to bill this person. And then the transaction is the past event. There is, oh, we have billed this person. This transaction has occurred. Or at least there was an attempt to bill this person, but it didn't succeed. But that is also in the past, right? It doesn't mean that it's positive. It just means that it's flowing into the positive direction of time, and it started in the past. Let's continue. So obviously, this is what I was talking about. This was Eve Golevin's post today, which is sort of inspired me to use the slides. So thank you again. If you're watching live, do let me know in comments. I would like to have a conversation with you, and perhaps even Eve, if you're interested, have you on the stream at some point to go into more detail about this. This is now my take on your work, but it is very much I learned a lot from you, and if I can, I like to share what the other people, experts who I learned from. I always find it to be interesting learning material to share on stream. So the idea here is that the patterns that describe the flow of data can be combined together. The before and after. You see there's a gray box. The gray box is actually the pattern. So in the gray box in the delegation, in this side, that will be the delegator. This is the aggregate root. This is downstream activity, reaction, event processing, projection, task processing, event generated, state transformation. Right? So you've seen this before. Delegation is something happens. Okay, when I call this API, you need to know that you need to let that other API know as well. Aggregate root is there was a decision. Okay, what needs to happen? This is your primary sort of transaction script or any kind of really API that you would post something to, either through a message queue or through REST. Downstream activity is then usually the read side of that, right? So this is, if you connect the dots, you can see that this one and this one, they are similar, but they are missing the events, and it's this projecting action that connects them together, right? So you can either have a what's the difference between an aggregate root and downstream activity? Well, the downstream activity just immediately shows you the new present state. That downstream activity is when I press button, turn menu off. When I press button, turn menu on. That's usually an animation toggle. That's downstream activity because it's not being persisted. The orange boxes are persistence. Whereas with an aggregate root, if you wanted to connect this, if I wanted a downstream activity that is persisted, I would combine the aggregate root with a projection, right? So it could go blue, 0 or many orange boxes, and then the 0 or many orange boxes, perhaps not the same ones, but aggregated in whatever way. Then they produce a projection. A projection is then the thing I see on my screen when I refresh some kind of screen, an API, do a GET request, or query GraphQL, or maybe I just get sent a payload through sockets, whatever it might be. And the really important thing is that, yes, there are exceptions, but the sort of craze for e-commerce, the most popular online businesses, especially B2B SaaS, B2C, e-commerce, logistics, warehousing, all up dashboard, so any kind of analytics, various A/B testing, traffic analytics, SEO and SEO analytics. Most software on the web and off the web adjacent, I would say, because we do have some viewers who are working in embedded systems. I do have to correct myself that not everybody is in the web. That most of them can be described with all of these 9 patterns or even less, right? So if you just understand what their nuances are, what the tricks are, like what can go wrong, I think that's most important. If you really understand what can go wrong, it'll already make you a better architect. And it'll also make it a little bit easier for you to communicate with your team. I just noticed I have that ugly background. I did receive your feedback, so I'm just gonna. Much better. Okay. Okay, so line of business is generally. I think this is 90. This is essentially e-commerce, WordPress, Gmail to some degree. This is your Facebooks. Without the stream, for example, the Twitter stream, the feed itself, that might be a much more complex aggregation, much more complex stream of projections and derivative projections. But this is basically what everybody's doing. Let's follow this. So, user sees, this is event modeling, by the way. User sees white boxes on top. These are UI elements. So arrows between UI elements, that is the user doing something on their screen, on their device, right? So what do they do here? They pick something from a list, they click this button, and this button is then going from the front-end app to the back-end app, place order. This is then processed. Okay, we go from blue to orange. This is then an event, so this is an aggregate. This gets persisted, and then it gets projected into some meaningful data matrix that is slightly different from the event. So you might say, when I order this, create an order, create my invoices, create me a list, a history of orders, clear my checkout, clear my cart, and show me some tracking information or whatever, and then show me a success page. All these sort of downstream activities are then projections. Anything that you might need to make a little bit more sexy to be shown on the UI, rather than just giving somebody PHP my admin access. And, there's the database, and this is what happened. And you sort of need to brain parse it. Like, we engineers, we love it, but users don't. Users really don't, especially on a small device like this. Right? This is normal flow, and specifically. Something that we easily miss, and when we're doing event modeling and we're writing tests, and I always ask them, what is the natural state of a user? Engineers often like to gloss over this first projection, right? So you need some kind of first projection, some fixture to even show something to the user, so the button even appears, so the button is even meaningful. We usually forget that this is really important, right? And then this makes a loop. So this, what you've seen here, this vertical, this is an aggregate ute, or specifically, if you're doing functional programming, it might be a decider of some kind. And what an actor is, which is the second part, which I think we'll start at about 20 minutes. An actor is a stateful decider, where you can take advantage of this state to build your architecture more concurrency friendly. So you can parallelize different actors by making them sticky to a certain user or to a certain aggregation context or specific aggregate boundary, using the main-driven design terminology here. So this is now going into detail. Yves, thank you. Yves, again, thank you for taking all this time to really document these. And I like the wording he uses here. He says it's used to protect the system when taking a meaningful decision. Protect in this case meaning that there are rules that need to be followed for the data, so to go from events to projections, there must be some rules that must be followed while the event is written. And it's the aggregate that aggregates all those rules, those invariants, so that when a command is triggered on the aggregate root, it is the aggregate root that checks, okay, this is happening right now about some future state. Am I allowed to create that future state and save it as a past event, right? So, it always goes past, present, future, past, present, future, past, present, future, orange, green, blue, orange, green, blue, right? So this is step 3, blue, and then blue goes to orange, and then green, and then you create this loop. And if you remember this slide, actually I lied, we start with green. But in order for green to not be empty, you need some kind of orange in the system, which is a non-empty table in SQL or Mongo or DynamoDB, right? So you usually start with orange. That's why we also usually teach them in this order. It's like orange, green, blue, orange, green, blue, right? And this is the annoying part to write, because this is the part that is hard to test. This has state. It might have state. It has invariants. It might have complex logic. It might touch other aggregates as well. It might be overlapping. So this is tackling sort of the meat and potatoes of most software architecture. Then we have the event sourcing downstream of this. So it's a downstream version of aggregation roots, where rather than saying, I will compute the changes and then write them to a projection to the database, that would be the typical, that's the green to blue, the downstream activity. Generally, there are so state-based systems are called state-based because they're not using event sourcing, because they throw away the orange. So it goes blue, orange, green, but they don't save the orange into a database. They just use it to compute the state, and then they put the green stuff into the database. But then they lose, then they didn't source the events, they are sourcing the state. That's why we call it state-based system. So if you have a WordPress, for example, is a state-based system. An accounting app, for a financial app, that might be called an event source system, because we have an append-only log of what has happened, and then we calculate the green, the state from that. So, you rather than having a table to query from, you would create a view, and then you would query the view instead. Just a little event sourcing distinction. Today is not going to be about event sourcing. It's complicated enough. Let's focus on the meat the meat and potatoes of CQRS, because we're about to get to the relevant parts. Task processing, you've probably seen this. This is usually your cron jobs. So there is a machine, which is the gray box here, the task processor. In event modeling diagram, this is usually a gear, or a squiggly, or like a robot emoji. You've probably seen me draw event models, but I use the robot emoji to denote this. What it's doing is basically saying, this is your typical subscription. That's the subscription. What needs to happen? Okay, today the calendar is correct, so today we need to create an invoice. That's task processing, essentially. It might also be, there's a calendar event on this day at, after 10 minutes before the event, send a notification if no notification has been sent. You might have seen that slide about the decision-making process of how Slack decides whether it will send you a notification or not. That is essentially task processing. Conditions unknown. And this I think this makes sense if we were actually listening to the talk by Yves. I don't want to go to too many details here, but it does highlight the core idea here, that you start in a product's context. You're watching the context of that product's API, let's say, and then it goes together into a catalog, and then you have an UI for that. It might be combining state from different places, so state from a user, state from a session, state from state from some kind of other derivative UI specific services, and then the user decides to do something, and usually that's boxed together into a command. the idea here is that the command, for example, if I decide to charge you something, that's a command. But if my transaction fails because, let's say, you don't have enough money, I can decide to retry that later. But what I can't do is keep the command unprocessed. Like, I need to specifically say, okay, we charged it and it didn't work, and now we need to decide how far into the future can we trigger another command, right? So the commands generally are extremely volatile. They need to happen as they have happened. You've probably seen this before. This is what happens when you what does it mean that the conditions are known only for a limited time? It means that if you start editing a document on Google Drive, Google Docs, and you lose internet connection, well, it's possible that all of your keystrokes that would normally be autocorrected or syntax highlighted, or maybe even sent to somebody who's editing the document live with you, while you're offline, that doesn't happen. So if you decide to hit F5, hit refresh in your browser window, it will tell you, hey, this has not been synced because the time of your browser is not synced with the time of the server. So you will lose data if you do this now, right? So there were commands that were not sent. Commands being your keystrokes, your text, etc. They were not persistent. So they stayed locally with some local versions of the events, but they didn't get to make it to the synchronization process with the backend server. And obviously, browsers nowadays have enough local cache and local storage and IndexedDB locally that you can actually just store it locally and then synchronize it later. And that's a slightly different pattern. That's specific to Google Drive and offline web applications, offline capable web applications. Then there's complexities in time. I don't want to spend too much time on that. Let's look into projections. So these are generally the most confusing. I don't know why. So I see a huge disconnect here between, let's say, the C# community and the Kotlin community compared to the PHP, Python, and sort of, the Django, the Ruby on Rails, the sort of more traditional 2000, late 2010 MVC frameworks. And specifically what's happening here is that PHP and similar languages were created as a state projector. Right? So you take the web, you take HTTP, which is a sort of stateless protocol, and you say, this has happened. There's a resource online. I would like to see that resource. And that resource is if we're talking strictly REST, that resource is a document of some kind or a JSON blob of some kind, but it highlights a projection of something that exists in that database, right? So it created this paradigm where engineers would just code to get the database contents in some meaningful format into the hands of the user. Those are the more traditional applications. And we call that boring tech, but that is really what defines most of the business activities surrounding web development. Wherever you go, you will find examples of this. Of course, of varying degrees of complexity, but nonetheless, you will find them. Checking on chat. Hello, you still with us? Do let me know. Is everything clear so far? Let's see. Let me know if you're following. If you have any questions. Is anything unclear so far? Maria had a comment, but journalists can only type and then not speak. Yes, so this is not a LinkedIn audio event. If you'd like us to host a LinkedIn audio event with Adrian, do let us know. Right now, we're keeping it to video streams, which means that audience participation is usually through chat, and we put it on the screen. My only gripe with LinkedIn audio, but LinkedIn audio live events is that they are not recorded, so they are peer-to-peer, they're live. You don't have a secondary backup stream to get them into users' hands after the fact. So it's a little bit less remote friendly, especially if we're in different time zones. All right. So where projections go wrong is that engineers generally mix up this idea of what do I have in the database, because this is not what most people are referring to when they are using projections. Because this, this idea that I have an API and it returns a payload, it's only a proper projection if it's projecting from events. So if it's a really atomic past tense fact, and then that is being aggregated, sort of replayed, in event sourcing terminology, sort of replayed through the timeline without side effects to capture what was written down, and then create the current state. So this might be when I created a product, when I added the product to the cart. At that time, this was the name of the product. Rather than saving an ID, and then you might run into this issue of, if I add something to the cart and then I change it in the catalog, does my product in the cart change name if I added it? What happens to my order history if I delete the product from the catalog? These kinds of questions. Yeah, if it's probably event sourced, there will be an event denoting a copy of really the important data. And then what you're really requesting from the server, from the projection in this case, from a API endpoint, let's say, that has a projection, that is serving your projection to a projector or some service, or you might call it whatever you want. This part, the gray box here, isn't really important. The important part here is that you need to know, you as the engineer, you need to know, if I'm in an event source system, I am using projections. If I'm not in an event source system, then what I'm using is, wait, which slide is it? So we can easily go back. If I'm not in an event source system, what I'm using is state transformation. So the thing in my SQL database, if I threw away the events, then the thing in my SQL database is state, is not events. So when I'm taking the state in two-dimensional form in SQL and I'm joining it with some other data to create a tree, and then I'm converting that tree to a DTO, to some JSON file, that is state transformation, not projection. And usually this is where most people who start doing CQRS and who start doing event sourcing, they get really bogged down on this detail, and it doesn't make sense to them. And the really important detail about, what's the difference, if it's already happened, what's the difference between it being in my database table or a database table in state form or in database table in event form? What's the difference, Dennis? Well, the difference is that past events, which are facts, they are much more certain that this has actually happened, that it is actually true, because it is immutable. Whereas the database that tells me what is Dennis's name, it only shows me my current name. It doesn't show me a log of all of my name changes. So the moment I change my name, or the moment I change my address, you no longer know what my old address was. And you lose this information that I've even changed my address. So if you're looking at a screen and then you refresh, if the name changes, you might not be aware. The user might not be aware that this name change was an important event. Whereas if you're changing an event blob that says Dennis has changed name on this date, that is a fact. That is a much more solid representation of something that I have did, rather than there just being the output of an update statement or an insert statement being run against the database. So that's a difference between event sourcing and state-based systems, state transformations. State-based systems, primarily on the GET request, they only do state transformation. You have state in the database, you query that state with the database with a query language. That query language gives you a query result. That query result usually use some kind of ORM for it to get into your language, so you're not using SQL, so you get some C# object or some PHP object, and then you convert that into some HTML, JSON, XML, protobuf, whatever. I mean, that's much less likely, but some kind of entity projection, some kind of data model that you can serve through the HTTP protocol, through the web, to some client device. Where were we? Projections, yes. So in order to really do CQRS, you need to understand what's in your database. So the thing that you think is a historical fact in your database, it might be a projection, not events. It's only really facts about the past if you have an events table or an event stream or an event store DB or like an event stream, like a timed sort of ordered log of events that have happened, within some boundary, within some aggregate or specific stream ID. Again, this is not event-driven architectures. That is when events are being used to carry commands or copies of databases, copies of data. This is specifically about when a change happens, do I save the change that occurred or am I saving the output of the change, right? So am I saving the update query or the result of the update query, which is the current state of the table? And then you have all these situations where it's the same person, right? So I do something, I send a command, the command is processed, and then I immediately want to read back what I have received. So generally what people get mixed up here is that this idea that I send a request and I get a response back. In CQRS terminology, these are two round trips. So it's a round trip where I convert the command to an event, and another round trip where I take the events that are relevant and I return a projection. And usually engineers, architects who are doing CQRS for the first time, this is where things get ugly, because if you zoom out, okay, slide 9, I have remembered this. If you zoom out, you might think that what you're doing is downstream activity, which is particular to a state-based system. Sorry, when I click it changes pages. So what you might be thinking is that you're doing downstream activity because you might not be used to thinking about the orange boxes as something that you also persist. So the orange boxes are persisted, and the green boxes might also be persisted or cached in the database or some other cache layer. That is usually when that sort of mental shift has to happen, and that's also why some people say that they just don't grok. CQRS, because this additional layer between the blue and the green box, the orange layer, it gives this illusion that there is something eventually consistent there, but it doesn't have to be that way. It can be in a single transaction, but there are two very separate steps. And you'll obviously see why is this a popular mechanism, especially in the event sourcing and event modeling community. Well, because the steps are more decoupled, right? So one, you either only change state or you only transform state structure. So that makes it extremely trivial to test cover, right? Unit test for, integration test for, because you have extremely granular controls. If you're a hexagonal architecture fan, you will also immediately see, as we're going to the CQRS loop, you will see natural overlaps with driving ports, right? So the blue thing going to the web protocol to the aggregate, that might be a driving port. The event then going out into a system that is capable of receiving events and converting it to something that might be a driven port on the event side and the drive-in port on the projector side, and then it again creates this driven sort of response, this output port back into the hands of the user, where they receive a adapted response, which is, okay, this was the result, and I am giving you the JSON version of that result, or I'm giving you the HTML version, the GraphQL version of that result. So have you seen this idea of reactions and state transformation and aggregates and projections and state transformation, aggregates, and delegation? These are the core ideas behind CQRS. So CQRS only uses these 4 or 5 patterns. So if you want to really take your architecture, so if you're very specific about your current architecture, let's say you've never done CQRS, you've never done event sourcing, it's very likely that all of your all of your experience with software are the ones that are in the corners. I said it at some point where I said most engineers only use 4 out of these 9 patterns, which is then defining what it is that they're missing out on, right? So, well, what are the 4 corners, right? So the 4 corners are all of the patterns that avoid using events, right? So there's delegation, downstream activity, task processing, and state transformation, right? And most engineers learn to code that way. But this, the really complex systems are in that middle bit. It's the aggregate roots, it's the event generators, it's the reaction. A reaction might be an animation to something. Our aggregate root might be a event source system that really separates out the side effect flow from the persistence flow. Event stream processing, that's batch aggregation, that's streaming aggregation, right? So really all the nitty-gritty, really interesting and complex software architecture happens in this middle cross. And obviously, this is not a beginner tutorial. You don't generally learn these in school, or if you're self-taught, you don't generally learn these with like simple katas, simple examples. So if you're one of those people, I mean, do shout out if you're in chat. Now, it might be me. Maybe I'm not seeing chat. So do let me know. I'm refreshing both screens now to check if I missed any of your messages. Or maybe we're just having a little bit more silent. Oh, I did the thing where I opened the stream on my other. That's always a bad idea. Okay, no, we're good. There's just no messages today. So generally what you would find at... I froze. We good? I'm back. Okay, sorry, I froze. I opened the stream on my other screen, and that usually causes problems. So if you want to learn CQRS, it's very... If you want to learn CQRS and you're struggling, it's possible that you have no tangible experience with anything in the middle cross here. If you're a PHP developer, Python developer, Django developer, Ruby on Rails developer, even if you're just using C# with like very simple concepts, like without any mediator, without any event buses, you will be in the corners here. And that's, considering half of the software engineering talent in the world are juniors, it's probably you're very heavily leaning on these 4 corners. And I would wager very heavily leaning on these 4 corners without task processing. So just this one, the delegation, downstream activity, and state transformation. Oh, you can't see my mouse cursor, right? Yes, you can't see my mouse. I'm sorry. I've been pointing at stuff with my mouse cursor. I'm sorry. Can I draw? No, I can't draw. Okay. Let's continue. So we were on this slide. So these simple patterns, if you add to your 4 corners that if you add some 1 or 2 or 3 of the event-based patterns, then you open the gates for a CQRS. Now you can do CQRS plus event sourcing. And CQRS plus event sourcing is usually a synonymous sort of usage architecturally, because CQRS is what you get when you do event sourcing correctly. Because it's very hard. It's very impractical to do event sourcing without the CQRS. So really, you can do CQRS without event sourcing, but the benefit really is event sourcing. It's using those middle patterns that are event-based. It's not about this idea that there's a write database and then there's a read database, and people think that is a sort of write-through, read-through, lazy cache strategy, and that's not the point. That's not the point. Okay, let's look at the reaction. A reaction. This is what most people think the events are about, because only this pattern captures event-driven architectures. So what is a reaction? A reaction would be there's an event happening on my PayPal. The PayPal calls a webhook. That's a reaction. Then what I receive is the command possibly carrying the event. So that's, if it's event to event, that is then event aggregation, right? Where I might have a Salesforce integration, and then they integrate events internally, and they allow me to have like a hose that gives me access to their event stream so that I can project them into my own events or into my own projections. This is very common in any kind of analytics, B2B SaaS, e-commerce related SaaS, where you just have a lot of data. And then you have to decide, do I give you the projection that is sort of more structured but clumsy? Because we changed the structure at some point in July, and there's a data break. Or do we just want to give you the raw events, but then you need to process them and sort of replay them through time? And you sort of need to understand what the rules are, what the invariants are. Here, Yves mentions this idea of signaler. Signaler is a C# .NET library for unidirectional sort of multicasting, broadcasting data messaging, usually to be used in web sockets or normal sockets, your UDP sockets, TCP sockets. Think of it like, if you're a Node.js developer, think of this as your sockets IO. This is generally what it would look like, right? So you get events, then events go into your front-end app, and then the front-end app, when it receives an event, it will call a method. It call something that an aggregate controls locally in my iPhone app, in sort of web-based iPhone app. Oh, Thomas, hello. Thomas is watching on YouTube. I am behind with the stream about 30 minutes. I wanted to ask if there is a best practice to create front-end for CQS of front-end to back-end. CQS pattern of front-end to back-end connection. That is a very good question. And thank you for mentioning that. I think we covered that to some degree already. I will get back to that. So thank you for asking the question. I will highlight it. I will sort of pinpoint it here for myself. And then I just want to finish up with the reactions. So the reactions are going into this idea that there are certain nuances to reactions. Some of them are guaranteed, and this has to do with, do they have at most once delivery? Do they have at least once delivery, right? So it approaches this idea of idempotence. Do we want to make sure it arrives? So are we going to send it twice? Do you just send it once because it's so ephemeral that when the next event happens, like a sensor, for example, a sensor reading, I don't really care if you send me 10 events. I want to know that I got the last one, because only the last one is correct. So the last one that was sent is correct, right? So there's this then whole time-based fuzziness that's going on, because I'm creating state from something that is extremely granular of the past, but it's covering a very volatile section of the past of time. Then you have delegation. Thomas, actually, we can highlight this now. I'm behind with the stream. I want to ask if there's a best practice to create front-end for CQRS pattern front-end to back-end connections. Let me change the bubble so that it's not that glaring white on white. Where do I do that? Is it this one? Yeah, okay, there we go. Is this better? So it's this idea that, generally what would happen. So if I understand your question correctly, is this regarding modern modern front-end frame libraries like React, where you have this middleware component that has state, and then you have this sort of problem of, I clicked the button, I saw it, it was okay, but that was a speculation, and then it went to the server, and only when the server confirmed, so it was optimistically, it gave me the thumbs up optimistically, so if I like somebody's comment in chat, it'll immediately update the front end, but then it goes to the back end optimistically, and then if it's okay, then it stays, but if it's not okay, it'll undo my thumbs up, or it'll give me a message of, oh, we actually showed you the thumbs up, we showed you the confirmation speculatively, but there was an error. Is it that kind of architecture problem, Thomas? I know you're behind, so you might not be able to. Anjana, where can I get these slides? That's a very good question. I'm very sorry. So this is Yves Go 11 9 patterns from Technorama 2023. Let me check where I got these. So if you Google, so it's Yves Go 11 talks Technorama. Oh, actually, that's a download link. So it's here. Let me see if that's the Google link. Thank you for asking, Anjana. Oh wait, I can't paste. That's gonna go to YouTube. Here we go. Link to slides in chat going now. So it's this idea that delegation, so front end, back end, it's this idea that there is a projection on the front end side that is being created by a projection from the backend side. So generally what we'd be talking about in that kind of application, if I go back to the slide 9, is that it is concerning the backend has a state transformation, and then the front-end app also has state, so it's more like an actor, but it's only serving one user, one device. And then it's also transforming state into its own internal state. So it might create state from the backend, converts it into state in some kind of middleware, into your like React apps store or state manager, and then it converts that state into events for the DOM or into commands for the DOM. It's like DOM, do this, DOM, remove this div, add this div, right? So it projects the DOM by giving it commands. So generally, you will see that a more complex architecture of backend does something like multiple microservices. It goes to a front-end gateway. It comes back together to a front-end application. The front-end application has also a pattern like that. You will notice that it's a series of red, green, blue, red, green, orange, green, blue, 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 from the backend to the front-end in multiple series. And then your front-end application generally sort of broadens this horizon by doing, orange, green, blue in multiple parallels by talking to a catalog API, by talking to a session API, by talking to a different API, usually governing either micro frontends or you mentioned CQRS, Thomas, where you might have CQRS, where you only have the command and query sort of segregation happening. But I think, did you use CQRS on purpose to know that it's not eventually consistent? Because usually people who differentiate CQRS from CQRS, they have this separation of my read events are very different from my write events. So generally, CQRS comes up in REST API architects. They would say, I have a GET request and a POST request, right? So that's request and request, but one is reading, the other one is mutating. But then you fall into this trap of, if the GET request creates a cache, is it still read-only? Like that's you get into this nitty-gritty of the architectural details of the underlying infrastructure of what is done in the sort of behind the scenes. Whereas in CQRS, you would say, I either have a command, which I know is talking to an aggregate, so there will be some invariant being protected, right? So that's this one, the top, the event with the command, the top one in the top column. Or I'm doing a query. A query is, I want a green box, right? That's a query. So it might be a state transformation, it might be a projection, or it might be asking for a downstream activity. And usually people use downstream activities. It's like, hey, I tell you to create this projection for me and only for me, and then throw it away. But it doesn't have to be the only way. Thomas, let me know. I know you're a bit behind, but I think you'll catch up sort of midway through the stream. There will be time if you're watching it on 1x speed or 1.5x speed. There will be time to follow up on this, so do let me know, and I'll be able to respond to you, so you can watch it later on the recording. Great question, Anjana. Again, super thankful for our regulars for joining us on both streams. Where can I get the slides? I just linked them. It's go11.com/talk/technorama23be. Fantastic 9 PDF. If you just type Fantastic 9 Go11, you'll find them. There's a link on YouTube. There's a link on LinkedIn for this event, depending on where you're watching this. If you're listening on Spotify, my suggestion would be to check out Crafting Tech Teams, my newsletter. I have a full history, like a full, how do you call it? Like a catalog of old streams, their recaps and their agenda, and you will find the link there to the events, to the YouTubes and everything, if you ever get lost. And you can easily index them over there. Thank you. Awesome. So we were on slide 31. Yes, delegation. Right, so delegation is generally, it's exactly what you think it is. It's the user has clicked something, and when the user clicks something, that click has to go to the backend, and then the backend essentially is clicking 3 other things. So backend is clicking something on PayPal, and it's clicking something on Stripe, and it's clicking something on SendGrid. That's usually what delegation is. So the user does something, and we then copy the intent of the user to 3 other services. So this is usually your kind of enterprise integration, this sort of glue code of this has happened. The user is doing this right now, so do that afterwards. And this particular complexity, if you add events in front of that, so there's an event that triggers this, so it's no longer the human's tactile action with the mouse, but it's actually an event that got logged and then sent to a Kafka instance, for example. Then you might already run into some issues with what happens if there's retries. Does it go back? Does the failure go left or does the failure go right? Right. So is there back pressure on failure, or is it going forward into a projection and then getting retried by some other automation? This is then when really the architecture starts shining and where actors also come in. If we can cover them, because I seem to be enjoying myself. Are you enjoying this stream as much as I am? I love these slides, so I'm in no hurry to go over them. There's 60 slides. I'm not sure why there's 60. We're on 34, but I am doing my best. So this slide, the Internet of Things, this is showing an event generator. If you remember, this is now on the middle cross section. So this is an event generator is when you take multiple events and then you say, oh, when I see these 3 events together like this, create a new one for them. Right. So usually this is in event-driven architectures. This is called event enrichment. Right. So when I receive that event, I will wait, and then I will receive that event. It's this idea of, okay, mortgage and loan and keys to the house. Right. So only when both things are synchronized, then I'll create a 3rd event. And sometimes that event then handles a command, or this is usually 5 people need to join the lobby, and then it starts automatically. That's essentially event generation, and then it might turn into event aggregation or event processing, depending on the volatility of, like, is this something that needs to happen to a high degree of precision, or does it need to happen with low latency, or are we creating derivative sort of mini events because we're enriching the state of where we are right now? So for example, you might be a user logged in, and every time a user logged in, you might decorate another event that says, okay, if the user logged in with a mobile device, what was the weather then? That might be a 2nd event that is essentially an event generator triggered by another event. So then, because later when you look back on this and you create a projection, you might decide to combine them or not combine them, or to combine them differently for the operational database compared to the analytics database. But this is generally used for things like A/B testing. This could be used for things like knowing what cohort a user belongs to. What is their acquisition channel? Did they click an ad? Did they not click an ad? If somebody uses a referral link, do they need to have some kind of discount? Airlines use a lot of this, to sort of manipulate the price of the plane ticket as you're looking for it on the web. So these are your more sort of large data stream enterprise-y integration patterns. And we can see another downstream activity on the right, where we can say, oh, okay, there's all these events happening. A certain combination of events triggers a different event, and then that event triggers a command for an automation, and then that automation just basically changes state somewhere. So this might be something like track the passage of time. Every minute, send an event of what time is it right now, and then when the time is beyond the time when the time sets, then denote we have gone from blue light to blue light filter, so trigger the command to paint my screen orange, right? And then the blue to green transition, the downstream activity on the right, is the reaction of, I'm not saving anything, I'm just going to change Dennis's screen to orange. That is an example of this event generator pattern. Sorry, this is the event processing in combination with the reaction. So this is an event generator. This is when you have a state of some kind, and then you say, okay, I know what has happened, and I want to sort of try to recreate what has happened based on the state in the database, right? So, and this I hate the most. I have to admit, this is what I hate the most. Like CDC, no problem. It's sort of mirroring the state change before, after, and then creating events. Like this has just been changed, this has just been changed, this has just been changed. There's two green boxes and events being generated from the deltas continuously. That's change data capture. It's very popular with event modeling, event streaming. Now, what I don't like is when somebody says, oh, there's a row in a database table, an SQL database table, at state, and then that row has a updated at, created at, modified by, last modified by, deleted at. That's my favorite. When you don't delete rows from the database, you mark the deleted at column as it's like non-nullable. And then you don't even have a is deleted. Is deleted basically means if deleted at timestamp is not null, then it is deleted. So you get this sort of double negatives in your architecture patterns, and that's already giving me a signal that somebody who should be using event sourcing only knows those 4 corner patterns, and they don't quite know how to create a time-based system in their database where a database row needs to disappear after a certain amount of time, or status needs to change after a certain amount of date. That is usually engineers who struggle with that. If you're struggling with that, it's because you don't know the patterns in the middle. It's like this. My status of me being enrolled in class is only valid until June 24th. And then the status needs to change. Now, a lot of developers, they will model it with the corners, which means you need what? Well, you need the green one and a cron job, which is green to blue, and then another downstream activity, which is blue to green. So on midnight on June 24th, the cron job needs to run, and then it has to happen without fail. Otherwise, there might be some weird consequences. But really, if you go even further back than this, which one is this? This is future intent that is uncertain. So I can just say, well, it expires on that date. So if I'm constantly computing, if I said I registered on September 1st and it's valid until June 24th, if that is a fact that has already happened, right? So it says when I enrolled, it already said what the validity is. Well, if I'm checking my current status, that is a projection based on that event, right? So that is a projection. That's the middle right one. Which means that if I query the system June 23rd, I'm enrolled. If I query the system June 25th, I'm not enrolled. Nothing has to change in the database because the projection itself is not saved in the database. It is being projected as I'm requesting it because it is time-based. It is time-sensitive. You've probably seen this with a lot of things like if I'm subscribed and I paid, I'm a subscriber, but then does a subscriber mean that I have a subscription, or do I need to have a subscription and I need to have a current invoice and need to have had paid it by the time you're checking, right? So there's all these like weird systems that developers do if they don't have access in their toolkit, in their architectural toolkit, in with the middle cross here with the event-based systems, and it's a huge disservice to your team because there might be a very simple way of expressing this, but you might be over engineering it with some complicated form of cron jobs because you're saving the projections, and the projections are actually dynamic. So because you've saved them, now you need to make the database alive. You need to make it self-destruct. You need to make it mutate itself over time, and that is very hard if you don't want to use triggers. And I hope you don't use triggers for this. Yeah, let me know if this was a helpful tangent. Okay, that's all the questions followed up on. Thank you. So what happens with event generators? Generally, this idea of deleted at, etc., you just want to monitor history. So if you want to monitor history, just event source it. Now, it might be hard for you if you've never done CQRS before, but my immediate suggestion would be just become self-aware of, are you saving state into the database or events? If you're saving state and the state is dynamic, then don't save it into the database, just delete it from the database. Or use the state that's in the database as a cache, but then have a clear separation of, oh, these tables have events and these tables have state, and the canonical source of truth are the events, not the state. Because I see developers who transition out of this. I mean, developers, teams, architects who transition out of this, they do it the other way around. They have the state, and then they have a history table for the state. And they use the state as the canonical source of truth. And that is a huge, huge headache. Because then you say, well, if I compute it from the log, it doesn't capture the state completely, because the state log might be immutable. You know, the same way that I say, oh, if I have an Nginx log and debug log in there, obviously that I can just delete that. If you treat a history table like that, then obviously you'll have trouble and you're not even solving any problems. Plus, you might not even have the table indexed correctly. You're opening yourself up to a huge headache down the line. My recommendation, if you need to generate events from state, make sure that it is being used like this, that the event generator is actually a small thing that is observing the constant state, and it is observing state. Okay, did it change? 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 Oh, it changed. Okay, I'm triggering an event. You know, this is essentially, if you're old enough to remember it, long polling with Ajax, where we didn't have push events, push commands from the server. So what we did was, I will remember what my current state is, and then I will query the server, and then I will compare what I have now, my green box, my state now, with my green box that I get from the server. If it's not the same, I will trigger an event saying, hey, it's not the same, this is what changed. Right? This is event generation. But it's a very inefficient way of polling, because you might have to understand the state to such a high complex degree that you need to reverse engineer sort of intent from the state. So depending on how heavily the state is aggregated, so for example, if my state has some average number, then I can't add an event that says, oh, somebody voted 7. You know, if I have the number of average ratings, then I can't create an event that says, oh, 7 was added. I can only create an event that says, oh, the average went from 7 to 6.9, but I don't know what the person voted. Now, I might reverse engineer if I knew how many votes there are, but then again, I need intimate knowledge about the domain complexities, about the data model, about how it is created, and then it's usually a upstream problem with your architects. The problem is that this can really rupture a team. If you don't have these responsibilities set up correctly, if every microservice in your system is communicating with other microservices by transferring state rather than events, then they will be tempted to sort of try to reverse engineer events out of those states. And if you've never done event sourcing before or CQRS before, it might be very tempting to misunderstand this and think that what you're actually sending are events, where in actuality you're just sending state, an aggregation of a projection of past facts. And stream processing is the big brother of just singular event processing, where this is generally being used where you do like some kind of merge join, a mapping join, flat map. This is your sort of reactive paradigm of programming, where I say, oh, I need to wait for 3 events from each of these channels, and then group them together, sort them, merge them, and then deliver 2 groups of events in this order. I'm not going to go into detail into this because this is not very specific to us for actors. It might be interesting to you if you're interested in like analytics or stream analytics. But I just want to continue on with the slides. I'm just going to check what we have. Downstream activity we mentioned. This is essentially a typical REST API post request. that doesn't use events. So this is your state-based general API. This is what you will call an API. You've probably known this. I would say this is the most primitive, least moving parts, and you can even see that, left to right, it has the least elements. But the problem is that the command, because it is protecting invariants, this gray box usually has two things going. It needs to process the command and possibly create some side effects, and then it needs to create a projection that captures the state of things as they are now. And usually you want to test the projection without actually triggering the side effects on a real system. And if you have idempotency or sort of retrial rules or deduplication rules, you might at some point encounter this issue of, well, I want the state again as it was before, but I don't want to re-trigger the side effects, right? So this is the idea of going to a welcome page. When you come to the welcome page, you get an email sent and you see the welcome page. Now, if I refresh the welcome page, I don't want the email to be sent again, right? So that already creates this, you've seen this in the browser. You go to the welcome page, hit F5, and they will tell you, this is a post request. Do you want to repeat the post request? It's like, no, I just want to see the welcome page. And then you do, and then if idempotency hasn't been handled, you get the email a second time. God forbid that you get charged twice. But that's really amateur. Usually what people do is they do the command to event state transition. They send the email, and they do a redirect from the post request so that you're not stuck in that post request, so that the browser redirects a GET request for you. This is your typical sort of landing page after like a success page from checkout. I'm sure you've probably seen this. But again, this is one of the it is one of the simplest, but also most primitive little tactical patterns here. And most people get stuck here. For most people, this is already complex enough. And they try to solve everything with this. And obviously this has huge discrepancies when you need to do like event-based architectures and sort of communicate with other systems that then can become quite a headache if this is all you know. System categories. Okay, so business intelligence. So this is the more analytics side. Okay, why am I lagging? I'm lagging, right? Video is choppy. Video is choppy. 1 2 1 2. Okay, we're good. So this is basically analytics. If you do any kind of database warehousing, business intelligence, having your operational RDS database on AWS, and then alongside of it some Aurora or some other, like ClickHouse, where you would have one database optimized for. Okay, why am I lagging? What's going on? Something's not right. Let me fix this. I'm sorry. Which tab is leaking? And I swear I closed most of them. It's Gmail. Okay. No, it's actually StreamYard. Okay, that's annoying. So, wait, what was I talking about? So yes, for analytics purposes, where you might have a operational Postgres or MySQL database or MS SQL, and then a secondary database, which is like Cassandra, ClickHouse, something columnar that is then optimized for analytics queries, where you sort of do range queries often, and you sort of can't really pinpoint an index. You just need to have the data partitioned correctly. And that database you would fill up with your events. And then for the analytics person, they would then create their own projections on the fly because they're basically just writing SQL queries. We have a response from Thomas. Thomas says, yes, as you mentioned, on CQRS in frontend, you have some state change actions by the user, and the user to have immediately a state change, not wait for something. This has to be done, but how? So again, here I would separate out what's actually happening, right? So when I give immediate feedback to the user from the front end, that is what? So again, that's the middle one on the timeline, which would be the present. So that's what you use for animations. So the middle box, that's green, that's a projection. Right, so what you're doing is you're separating out this idea of the user is doing, there's an event that's happening. So the user is calling a command, and the command is now doing two things. The command is actually doing event sourcing to the backend, but to the user, it will just do a state transition where I will go blue to green immediately. Right? So you have one renderer which says, what is the optimistic case of what will happen on the UI? That it happens on the front end, that's blue to green immediately. And then at the same time, there's a backend request which actually goes to an aggregate. It validates the aggregate, saves events, which is the persistence part, and then it sends back a projection. And usually, in order to make that kind of CQRS on front end seamless, you would need to have at least the architecture of the green box, the projection that came back from that response, and that was created by the optimistic button logic. Those would need to match, and then the server would just say, okay, here's the actual state, and then the front end would say, oh yeah, this is the one I already predicted. Now, you might say front end, but there's actually a much older version of this, which has nothing to do with HTML and web, and it was created by one of our geniuses of our time, John Carmack, and it is client-side prediction on the Quake World engine. You know, if you know the game Quake, Quake World was a separate client that was created for Quake to really take advantage of broadband internet as it started booming in the early 2000s after the dot-com bubble. And he had the same problem. When I have a weapon that's instantaneous, well, I want it to be instantaneous on my screen on the client. I don't want it to go to the server and then the server to tell me, yes, it was instantaneous, because I will have moved my camera at that point. So if I'm shooting my railgun and it's supposed to go straight, if I'm waiting for the server to give me feedback, well, then on my screen, the line will be crooked and it will be like slightly off. So how do they solve that? Well, by animating you a client-side prediction. And what they actually did is they event sourced the UDP packets, and they played the hit scan of whether you hit the target or not slightly into the past, right? So they had a complete timeline of whether you hit a target or not, and then they adapted it to, okay, on your time, at 10 seconds, if there's a 1 second delay, at 10 seconds, I know that you have already predicted that you have hit the target because you saw the target on your screen on your cursor. So your UI has predicted that it will be positive, it will be optimistic. So when it comes to the server, we're at second 11. So at second 11, we have a full history of what was the state at second 8, what was the state at second 9, what was the state at second 10, what was the state at second 11. So what this system does, it then checks, okay, if I go back in time to second 10, would you have hit that target then? And then it says, yes, you would have hit the target. So at second 11, it says, okay, you've hit the target. So only the audio delay of hitting the target is delayed, but you actually hit the target based on what you see on the screen. This is like typical CQRS with UDP packets that was created for like low latency online gaming. And usually the React button giving you immediate feedback is exactly the same kind of problem, but where you're solving it with like slower protocols like TCP over the web, which is really curious. It might be a bit more efficient doing it with the WebSockets, but I think just for a button click, like a React, and then having like sort of a secondary projection might be much more trivial use case. Another thing that can happen, regarding server-side prediction in these kinds of games. Thank you, Thomas, by the way. This is a great question. Server-side prediction with games, what can happen is that each of your clients can be lagging there differently. So that each client might have a different delay. So you might need to have a strategy of how to deduplicate these events, how to order these events, how to cut them off, how to say, okay, I'm not waiting anymore. Like if you're lagging, then it's a no. There needs to be a strategy of how to get there. I am lagging somewhat, so I'm not sure what's lagging. Where's the camera, or is the camera overheating? No. Okay, let's just continue. A few more slides. So that was business intelligence. So taking your events, ignoring the SQL projections that you've created, and putting the events in their raw state into some other database to create more analytics optimized projections for some other use case, or for a use case where the user, the business analyst, comes in and on the fly, the structure of the projection is not knowable until the analytics person has a problem, and then they will create a report which might take a long time, which is why they're doing it on a separate architecture, separate from the operational database, which might be hot. And then you have state transformation. Again, this is one of the primitive patterns. This is your typical PHP. There is state in the database. I want the state in the database using some rules to be converted to a state in my front-end application, by virtue of converting it to JSON and then transferring it down. And maybe you have a React application on the front end or a jQuery app on your front end, like a jQuery library. Then you're doing the same thing on your front end. I get state in my jQuery payload. It's a JSON payload. And then I change, based on that, I change the state of my DOM. Or with modern technologies like HTMX, that's exactly what it's doing. So the state that's being carried is actually HTML. And you say, okay, this HTML needs to go to that DOM node. Okay, it's going to that DOM node. And then you enrich it with behavior that doesn't need JavaScript. And then part of that payload can also be JavaScript so that it enriches itself. That's the sort of modern HTMX web component way of replicating what React and similar frameworks or libraries are doing without JavaScript. I do need to correct myself because people usually tell me that frameworks, React's a library, not a framework. Pet peeve, sorry. And then you have the more typical use cases here that Yves mentions on his slides. So there are transformations. I think we just went through this, when you have this sort of, I need it from the database to my PHP app, then the PHP app converts it to JSON, and then the JSON goes to the front-end app, and then the front-end app uses the JSON to load it into my DOM, if it's HTML. Or if it's not HTML, what might be happening is this is more of a backend example on screen where you have state in one system and then you convert it to like XML, you send it over to some client, and then it arrives in some other system, and then it goes into some slightly different database, but it carries the same information. But it's you're doing extension, you're doing structure transformation, not so much data transformation, which is essentially what reporting tools are doing. Okay, now, Yves, I didn't check these slides. Yeah, okay, so this is just your typical Saga. I don't want to go into choreography. Yeah, so this is just, this is actually what we've mentioned earlier. So this is your product category, the user that there's a product category, that there's a cron job, that it could trigger some action. That action is being mapped to a aggregate. The aggregate decides, yes, this was correct, this has happened. Right, so this is your subscription. It's the 17th. I need to trigger new invoice for Dennis. Okay, new invoice was requested. Then two things happened. One is, and this might be double bookkeeping. So trigger the event flow on the receiving side, on the debit side. Trigger the, I'm sorry, I'm not going to pretend I know accounting terminology, but trigger the positive side, trigger the negative side, and then once that is synchronized, react to it by saying, okay, we're now ready, numbers make sense, send an email. And then that updates somebody's report somewhere and prepares the cron job for the next cycle for tomorrow or for next month. Okay. Key takeaways. This is still slides from Yves. Most engineers are in this sort of CQRS state without knowing events, which might make them a little bit clumsy if all they know is the patterns in the corners. So blue to blue, green to green, blue to blue, blue to green, and green to blue, and no, that's the ones. And green to green. Yeah, sorry. So if that's where you're at, I recommend picking up some kind of event pattern, right? So if you're, for example, you can check out the slides. Slides are already in chat. I just want to go back to slide 9. So what happens here? You have a backend engineer, a front-end engineer. They say they want to learn event-driven architectures or event sourcing. Then it's what the heck? What the F is this? If you start doing DDD, the DDD, the green book, the red book, the more modern books by Vlad Kononov, they will tell you to start learning this process from the top. So they will tell you, okay, aggregate root, and then learn from there. Rather than projecting states, persisting states, start persisting events, and then go from there. That's your typical DDD mantra. Start from the top in the middle column. Now you have the cloud-based, more serverless, Vercel, AWS, Kinesis, Firehose. They will tell you, okay, you want to learn event-driven architectures. Okay, so you need to go onto the left side here. It's like, okay, well, you want to learn functional programming, so I will send you an event to some serverless function, and then you trigger it, you spin it up, and then you make a decision, and then you call some third-party service, like send an email. That's the left one. That is the reaction. That's serverless, right? So that's already different. One person here is a backend developer. They're starting to learn CQRS or actors. The other one is a cloud architect. It might not even be an engineer. It might just be a solutions architect and need to draw a diagram for how the reaction is behaving. Then you have the fourth variant, which is typical event sourcing. It's like, okay, well, if I want to render this page, how do I render it? Well, I can render it using a projection. Now, I don't know what the structure needs to be, so I'll just save my facts into the database, and then I'll experiment as I go. That is your typical event modeling advice about how to go about these things. And then there's the event generator, which is the more mature, slow, bureaucratic, enterprisey way of saying, well, we have this very old system. Let's treat it like a black box, and let's create new events into our new system where we will then experiment with some different architecture. These are your strangler fig patterns. These are your enterprise like Salesforce. These are your Kafka-led CDC, Panda, Red Panda, sort of, I am not touching this legacy code. It has green boxes all over the place. I want events from that, and I want to create my own new brownfield system. And then the one in the middle, that's usually for actual data processing pipelines. That's your map reduces. That's your sort of aggregation cycles. Maybe you have multiple event streams and you sort of need to merge them, you sort them, group them. So that's your more typical functional reactive programming paradigm. And then you combine them together. When you combine the top right quadrant, you get CQRS. Bottom left quadrant would be what you would need for cloud computing, for like cloud-based serverless architecture. The top left would be your typical sort of front-end application, and the bottom right quadrant, so the middle and the bottom right sections, those would be your typical, let's say, event-based, sort of more modern, dynamic, animated UI. So that's more of a front-end engineer, sort of full stack paradigm. Okay, one more question from Thomas. I'm just going to drop the slides. I am lagging, and it's not the slides. Sorry about that, technical problems today. Thomas, but what if you have no clue about the prediction? The front end is unable to predict the resulted event of the command and also not the resulted state. Well, then you can predict that you don't know. Then you might disable the button and show a little spinny, right? And then you make the spinny go away when the actual result hits. And if you're not happy with that, you can make the spinny stay for a few seconds. It's like, okay, you click the button, it's like faded out. Then by default, in 5 seconds, you show an error state, and then you essentially abort the error by getting the actual response. I'm sure if you look at front-end integration patterns with one of the more modern frameworks like React, Next.js, the T3 stack by Teal, or if you follow Nick Shoemaker, I can very much wholeheartedly recommend. Nick Shoemaker is working in fintech, and he basically manages the architecture of a enterprise scale React application. So that's really like very pedantic, really very well structured, very well organized code base about how their React components are structured, separating behavior from UI to design, accessibility, and degradation, in usage depending on what device you're on. And can wholeheartedly recommend checking out his work as well. He posts a lot on LinkedIn. It's Nick Shoemaker. He was also a guest on the Technologies podcast and a dear friend of mine. Thank you, Thomas. So if there's no further questions, I'm just gonna check out Vikas's link now. Vikas, I don't know if you're still with us. I know this took like a whole, my estimates were off, so I'm not where I wanted to be with the slides, but I can show Vicas's link. Which is the actor model. Let's read this. Well, the actor model. Orleans is based on the actor model. The actor model originated in the 1970s. Blah 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 blah. Actually, ironically, this book also has actors and visitors. I don't think it really does them justice. So what you really want to capture with actors is essentially what you would want with. Do I have it here? Yes. So what is an actor? If I look at it from the perspective of from Yves's design, you might think that in a naive system, these boxes, the top 9, are stateless. And you might be correct. This might be your typical microservice, your typical stateless sort of web-based server. Now, when you're dealing with concurrency, you might get into this trouble of, well, I want certain things to be parallelized. I don't really want them to go orchestrated end to end. I want them to be sort of have like worker pools in the background. Then I want the supervisors of the, let's say, the aggregate routes, I want them to sort of work together and sort of put things into worker pools together. But I also want it to be atomically responsive backwards. So maybe I can send back a response, or maybe send multiple responses for doing Internet of Things. So what an actor is, let's say, an aggregate. So it has an identity. It has some kind of address. Think of it like an address. You say this one officer, and it has state. Right? Think of it like your mobile application being an actor. When something on the backend happens and I need to receive a notification, I need the server to know exactly that it has to talk to this one. When I copy paste on my iPhone to my iPad, it knows exactly which device is which and where they are and whether they're close to each other, proximity wise. And that is, what you would call state. But state can also be that it just has, in event sourcing terminology, that the aggregate itself is reconstituted from its own events, but it doesn't use a projection. It doesn't use a green box. It just keeps its state in memory, right? So it doesn't do this thing that what is it called? That a downstream activity would be doing, where I say, I get an event, and I check the database, and then I send the response. But it's going to this different flow of, I get a command, and I have my state, and I send you back the response based on my state. And if you wanted anything persisted, then I will write from my state to the database after I've already responded to you. Right? So this event sourcing idea can then be synchronized and sort of locked or unlocked or reordered in a different order so that you can have higher concurrency. And really, the source of truth is what is inside memory. And you're not playing this game of the database is my boss. No, it's this instance that carries this particular actor with this particular identity, and this identity is locked. It is preferred, let's say, that only this instance, only this node serves this address, serves this identity. These are generally, actors generally go well together with message queues, when you have consumer groups in your message queues, and then the consumer groups have consumers, and the consumers will have state. Redis streams work like this, Kafka works like this, where you have a consumer group, where you have an event queue. The consumer group will then be just a gateway, and then there will be one consumer. And you might assume that each of these consumers is then one actor, right? So they have slightly different identities. Now, they might have identical identities and they're just being load balanced, or they might be catering different kinds of messages based on what's coming in. But generally, what an actor is it is a stateful sort of aggregate that has an identity that can be addressed, that somebody can say this one. And generally what happens is, rather than it being a request and response paradigm, rather than saying it can have multiple requests and multiple responses in like one unit, what's actually happening in actors generally, and this is now drawing inspiration from Akka, the way Akka does actors, is that it can receive multiple messages. They are ordered. It'll only process them one at a time, but it can do so extremely quickly. And then if I label these, let's say 1, 1, 2, 3, then you can say, while I'm processing them, if I'm processing 1, I might respond to my sender, but I will respond more than once. I might respond more than once. So I will send one response and I'll send another response. And then I'll have 2, 3, and then I'll have another 2, right? So that is how you would typically, that is the degree of freedom that you typically want to have with an actor architecture. And so these are the responses on the right side, these. And why is this important? When would you use this? You would use this, for something like a stock market prediction, like something very high speed, low latency, and high concurrency. Or if you're just doing an event-based architecture and you have a centralized server, if you have like e-commerce and it's Black Friday and you just want it coming in, but you just want it to be very predictable, like it's just a huge hose of data, and you want the event message, the processing of the event, to be extremely one-directional and predictable, even at high volume. Obviously, you would only use this if you need state. So not all applications bode well with actors, because if an application doesn't need state and it doesn't need a sticky session going with the actor instance, then it's just going to be a huge overhead of locking things and notifying them. And it's worth noting that another property of actors is that they communicate with other actors. They might even spawn actors. So an actor might be something, this is your typical Go coroutine, or your Go, what is it? Go function, Go routines. I think it's called Go routines. It's what the Go keyword does, right? It spawns another thread, well, another process, a sub process that is sort of masquerading as a thread, and you can sort of share data with it. But rather than managing channels and managing responsibility, you really just spawn an actor, then you communicate with it and supervise it. Supervise it in the sense that if it crashes, you are responsible for restarting it. So it might have another actor here, another worker here, and then all they're doing is that these responses are essentially just messages that it understands, that it receives. So there isn't this request-response paradigm. It's just this event-driven paradigm of, event received, okay, send this downstream and send this to the sender, right? So I can send the two things. I can send this to the sender, the one that sent me this, that would be the response. And then I can send these other 3 things to other message queues, but I don't know who will process them. Or I might send them to a worker pool of actors, so I will know what kind of actor will process it. So I have that level of coupling and control, but I don't know which one, because they have like multiple responsibilities. So Thomas chiming back in regarding the CQRS. No, I don't want to let users wait for anything. This is also the reason why I'm using CQRS. Otherwise, I would not use CQRS. So what we have on screen right now is actually a very good example of that. What you can do is you can say, when the user clicks on something, I will separate out the idea that the button does something by default, and there is then a correcting behavior coming from the backend server, right? So you might not be able to predict what will happen, but you might say, I know what the most likely outcome will be, right? So when I say a Reddit counter is a good example of this. So when I upvote a post on Reddit, when I click the up button, the likely thing that will happen is that the number of posts, the number of upvotes goes up by 1. Now, if I loaded the screen an hour ago and I click up, it goes up by 1 because of me, but it might have also gone up by 20 because of 20 other people who have voted in the meantime, right? So yes, when you predict on the client side, yes, obviously it will go up by 1, but then once you hit the backend, it might also correct and saying, oh, it actually went up by a little bit more than 1. But at least the up arrow stays orange, right? So that would be my suggestion of how you can model this. Like, it's like separate this idea of what do you predict for me to happen from like my actor, and is the data that I'm looking at an aggregation of something, and what could have other people have done in the meantime? Like maybe it went down. Maybe it actually, the up button is orange, but it went down because I added an upvote and 40 other people added 40 downloads. So even though the prediction said it goes up, when it gets corrected by the backend server, the votes actually went down. So I didn't go into too much detail on actors because I just want to keep it very much architectural. I can recommend a very good YouTube video. Wait, what do you see? Do you see YouTube? No, you see this. Okay. YouTube actors. So I can recommend this video. No, not actors. Yes, this talk by Tech Talks at AppNexus. I can't show it on stream because it's just gonna make my YouTube unhappy, but I can share the link. So this is what I would recommend you check out regarding actors to essentially get a 1-hour version of what I just told you. The practical part. So Nicholas Ockett actually mentioned that he had some blog about Akka, about actors. I did promise him we would check that out, so let's do that now. So the idea with actors is that they are aggregate roots that have supervision, so that you might have this idea of have one aggregate root and that might communicate with other aggregate roots, and one of them is the boss and it's supervising the other ones. You might have seen this with clean architecture, and especially use case driven architecture, like streaming architecture, where you have this idea of one of them is like the main one, but then downstream there's like these like little transactional things that are really aggregate entities, and the root is just like this big mofo that's sort of encapsulating a huge domain. But it might not be that way. It might just be encapsulating a huge infrastructure. You know, when you have worker pools, it's the infrastructure that's complex. When you have a huge overlapping domain, it might be the domain overlaps of, well, the cart and the logistics and the warehouse and the email needs to be synchronized, and the tracking needs to be synchronized. That might be a domain overlap. Infrastructure overlap might be, well, we have 7 different tenants, but they're on the cheap tier, so they are sharing resources with each other, right? So we just send it out. You know, this is your typical like AI-driven SaaS, where you say, okay, process my video, please. And then if you're paying the big bucks, you get your dedicated actor. And if you don't pay the big bucks, you get like a worker pool shared with other users. And there's a supervisor that says, okay, I will send it to the first one, but I don't know when that will happen. And then, you know, I will send it here in one direction, and then there will be a response at some point coming back. So he mentions, you know, so this is very Akka specific. And then, yeah, it can generally be a hierarchical system where you have multiple actors controlling other actors, and there's this sender and receiver relationship for each message being processed, while also the aggregate itself having an owner, having a supervisor, or having somebody that spawns it. So you have 2 different hierarchies: the hierarchy of the message, the request flow, and the hierarchy of like, can I crash? If I crash, what happens? Right? So it is creating this sort of railway system where if something exceptional happens, like an exception thrown or an error or something like failure, it lets the supervisor know, not the user. Right? So that's why these kind of systems are very fault tolerant, because the user just sends a request, there's an exception. Okay, the exception doesn't go to the user like it's with PHP. The exception goes to the supervisor. Supervisor reboots the actor reprocesses the message, and then it sends the response to the user. Right? So that's the idea behind this. That's the power. Now, you might never need that kind of architecture, but today's stream is about that, and I figured I would let you know. And specifically with Akka, so this is a very, very popular thing, especially with other systems that are actor-driven, especially in Erlang, you have this sort of guarantee of isolation, of process isolation. So they have this sort of very aggressive strategy of, if there's something wrong, if there's an exception, just let it crash, and then we'll restart it and we'll process the message again. Rather than there being this whole try catch on error, then do this, do that, yada yada, that letter Q, blah blah blah. Right. So it has the actor pattern is more to do with the state of the actor, of the aggregate, and what should happen to make it more fault tolerant, because the behavior it exhibits at fault is what will determine whether or not it will be responsive at high load. Yeah, so that's that. So this is another. So this is about coding.com.blog category Akka. This is Nicholas Ockett's blog. I'll also post it here. So the actor blog by Nicholas. That's it. And then on YouTube, one more remark from Thomas. Thomas said, okay, this is what I'm actually doing right now. Is there a collection of best practices in front-end dev in CQRS? I'm not sure. I would love to get back to you on this, because I do need to jump off now and perhaps check on the little ones. Hear some screaming in the background of the babies. I'm sure there is, but I'm not that well versed on front-end. But I do have a lot of people in my network who are. So if you don't mind waiting for a bit, I will check on this, and then I'll maybe let you know. I'll definitely message you on LinkedIn, Thomas, and if I find something interesting, I'll even write an article about it. But definitely, thank you for your dedication to the stream. Thank you for all the questions, and I think you caught up with the recording. So thank you for your commitment, and for all of you who are still here, thank you for your time. Thank you for giving me this time to be with you, to be of service, to be educational, and I would like to think entertaining. So next week is going to be really action-packed. Next week is going to be Tobias Mende on Wednesday, and we have Brian Finster on Thursday. So it's going to be leadership and DevOps from the top experts, from the top, let's say the more modern generation of thought leaders and influencers. So really excited about that. Have a lovely weekend. Do network in chat, connect in chat. If you're not a follower, I think you are a follower. I think you might be a follower on our newsletters. So if you would like to, why does that not show up? Because it has to be this one. Yep. If you're not a follower already, I would invite you to follow the newsletter. And I am now signing off. Thank you so much. Yeah, so Nicholas mentions, thanks for your reference. The blog is old though. Just saying. Okay, I see that we also have a little technical issue with StreamYard. Thank you for bearing with me. And I'll see you all next week. Take care. Ciao. I'm gonna sign you off with some lovely elevator music, if my stream doesn't crash in the meantime. Ciao.